Let's factor this. So we're going to start with our rational zeros theorem and list our possible rational zeros. So we have our constant over our leading coefficient. So the factors of my constant, factors of 12, so I got 1 and 12, 2 and 6, and 3 and 4. Oops, plus or minus. And my leading coefficient is 1, so that's plus or minus 1. So that's going to give me 1, 2, 3, 4, 5, 6, 12 possibilities. I'm going to list them in numerical order just because. And we can now start with our synthetic division. So I am going to have you pause the video at this point. Don't forget your placeholder in your synthetic. And I want you to try out our list of possibilities until you find one that works. Use that one to write out your multiplication statement, and then come back to check your multiplication statement to see how you did. Ready, go. Okay, I tried positive 1 first, didn't work. Tried negative 1 next, that one did work, gave me a remainder of 0. So if x equals negative 1 is my root, is my 0, in factor form that is x plus 1. Remember, you do your x equals negative 1 and work backwards. You add 1 to both sides to get it to equal 0. So x plus 1, and then here's what I'm left with. Now I look once again, I need to do my synthetic division again with my leading coefficient and my constant as my possibilities. Constant and leading coefficient are the same, so we have our same list of possibilities. I'm going to have you pause the video again, find a 0 that works. And remember, just because it worked the first time doesn't mean it's done with. You have to keep trying it until it doesn't work anymore. However, if it doesn't work the first time, it will never work. So plus 1, we don't ever have to try that one again. However, we should probably try negative 1 again until it doesn't work. If that doesn't work, you just keep moving down the line. So pause the video, find a 0 that works, and then come back and we'll check our multiplication statements to see how you did. Let's see how you did. I tried negative 1 again, didn't work, so then I moved on to positive 2. Positive 2 did work, get a remainder of 0, and this is my answer. So now I have x plus 1 from the first one, and I have x minus 2 from that one, and here's what I have left. We are so close. We only need synthetic division to work one more time, and then we're down to our quadratic that we can factor or quadratic formula on. So, one last time, pause the video, find a synthetic division that works, and write out our multiplication statement that will finally be down to our quadratic. And remember, we can't take positive 2 off the list yet because it hasn't not worked yet. So, pause the video. Find one that works and write out your statement, and we'll see how you do. I tried 2 again, and it did work again. So that means in my factored form, x minus 2 now has a multiplicity of 2 because it worked twice. And what's left, I have x squared plus 3. So I come over here. I am almost to my fully factored form. This is where we would have ended last class. However, now we know that this is not difference of squares, but it is sum of squares, which means it factors as imaginary. So square root of x squared is x, square root of 3 is square root of 3, but we have I, because sum of squares is our imaginary, and x plus root 3, I. So that is our fully factored form. Now that we have it fully factored, we set them all equal to 0 and solve them out to get all our roots. So I have x equals -1, x equals 2, and this one had a multiplicity of 2. It happened twice. X equals √3i, and x equals -√3i. Notice that once again, your imaginary one came in pairs, just like we mentioned at the end of the last video. Imaginary will always come in pairs. So here's all my zeros. It was degree 5, so I said I should have 5 zeros. 1, 2, 3, 4, 5. Still have 5 zeros. Now, before we end this video, we're going to talk about B really quickly. It says F2 linear and irreducible quadratic factors. Here's what that means. An irreducible quadratic basically means if your quadratic factored to imaginary, don't factor it. That's what an irreducible quadratic is. It means your quadratic that only factors as imaginary, don't factor it. So this right here, that is actually our factored form with irreducible quadratics. I took my quadratic one, and instead of factoring it down to imaginary, I leave it alone. And that's my factored form with what they call irreducible quadratic factors. So that is all for this example. In the next example, we're going to do the same thing with something to degree 4. So more practice, and this time I'm actually going to give you one of the roots.